Hello and welcome back to today's video. In today's tutorial, we'll be talking about how to load our first definition file in SCAPS Simulator. I am Emeafu Francis and I'll be your guide. So, when you launch the SCAPS Simulator, the first thing you come across is the action panel. And why do we even want to simulate a solar cell in the first instance? The reason for trying to simulate a solar cell is to be able to get the characteristics of the solar cell. Most PV manufacturers use the standard test condition to be able to ascertain the robustness and the efficiency of their solar cell. And some of the things that are being tested during the standard tests condition are the open circuit voltage, the short circuit current, the fill factor, and the power conversion efficiency. With these parameters, you can be able to state the performance of the solar cell. Now, what are the standard conditions that are required for testing a solar cell? The standard conditions include the solar irradiance, which must be 1000 watts per meter square. The temperature must be at 25 degrees centigrade, which is also 300 degree Kelvin. And the air mass must be 1.5 standard spectrum. Now, looking at this interface, we can see that there are several sections. We have the working point, we have the action list, we have the illumination section, we have the action where you set the parameters that you want to test, we have the set problem section, and we have the result section. We'll be looking at all of these different sections in little details so that we can understand them for use in our simulation process. So what do you do in the working point? The working point helps to specify the parameters that are not varied during the measurements, but are relevant for measurement in a simulation. One of them is the temperature. The temperature must be at 300 degrees Kelvin. The voltage can vary, but usually once you launch the software, it's preloaded to 0 volts. The frequency is also preloaded and the number of points is also preloaded. These are standard conditions that are used for simulation. There are cases whereby you will be needing to change the values, but for the start, we will be using these values. Now, the temperature is the operating temperature for the solar cell, and it is useful for some parameters that are dependent on the temperature. For instance, effective density of states for the conduction band and the valence band is dependent on temperature. So this temperature must be loaded. The thermal velocity for the electron and hole also depends on the temperature. So the temperature has to be loaded. The thermal voltage for the carrier transport analysis is also dependent on temperature. For that reason, the temperature has to be part of the standard parameters. The voltage also specifies the starting voltage for simulation. Usually, the voltage for measuring the capacitance frequency and the quantum efficiency is loaded, and it is relevant for the DC bias voltage. We have the frequency. This is the frequency at which the capacitance voltage measurement is simulated. So you can see the frequency, and then the number of points determines the number of steps that is relevant for the IV curve, the capacitance voltage curve. Now let's go over to the illumination section. The illumination is relevant also for solar characteristics measurements. You can either simulate the solar cell in the dark mode or in the light mode. Now in the dark mode, most of these parameters will be grayed out and you just test the IV characteristics or whichever characteristics you are checking up. But when you select the light into the light mode, you have to also select the light spectrum. Preloaded when you launch this software is the AM 1.5 light spectrum. Now, if we look at these parameters in details, light/dark toggle selects whether you want to simulate the solar cell under the illuminated condition or under the dark mode. The analytical model / spectrum from file helps you to select the light spectrum for the simulation. When you click on this select button, you can now select the light spectrum. For SCAPS Simulator, there are different light spectrum that has been preloaded. They were generated by taking measurements of actual light spectrum in real life, and after several accumulated results, they are now collated and loaded for use in the SCAPS Simulator. We have the spectral cutoff. Here you can actually select yes or no, and if you select yes or no, you can now be able to select the cutoff wavelength for the light spectrum. You can set the short wave or the light wave or the long wave. We have the neutral density. It adjusts the intensity when using natural density filter. The specify illumination / directly specify here. When you are in the light mode, you can use this button. When it is in the dark mode, this button is greater, it doesn't work. Once you are on this section, once you select this section, this analytical model for generation comes up. So you can now be able to select the generation rate for the analytical mode. You can also import the generation mode from the system. We have the constant generation mode, which specifies a constant photo generation rate for uniform light intensity. The transmission attenuation filter adjusts the light attenuation during simulation. So all of these are done with this panel. Now we have the action panel, where you select which of the parameters you want to test on the solar cell. Is it the current voltage characteristics, or the capacitance voltage characteristics, or the capacitance frequency characteristics, or the quantum efficiency? All of these can be set in this action panel. Now, the current voltage characteristics is for determining the fill factor, the efficiency, the open circuit voltage, and the short circuit current. You also set the minimum and maximum voltage that is required for this curve. Now you can select the stop after VOC to automatically stop the simulation for the IV curve when the open circuit voltage is reached. Now the incremental steps states the size for the voltage increment. It can either be 5 volts, 2 volts, 1 volt, depending on your settings. Now we have the capacitance voltage characteristics simulation. Here also, you check this box and you put the minimum and maximum volts for which you want the capacitance voltage simulation to run. You also select the number of steps that you want for this simulation. You also put the increment. The increment determines how it increases. We have the capacitance frequency characteristic simulation. Here you have to impute the minimum frequency at the maximum frequency range for which you want the capacitance frequency to run. The points also states the number of steps that the simulation will have to undergo. We have the quantum efficiency. The quantum efficiency also relies on the wavelength, minimum wavelength and maximum wavelength, and you can also put the number of steps you want to achieve. This helps in simulating the quantum efficiency, that's the incident photon to current efficiency of the solar cell. Now we have the series shunt resistance. The series resistance enables or disables the series and set the ohm value. So once you click on yes, you can be able to set the ohm value. For the shunt resistance also, when you click on yes, you're able to set the shunt value. You can actually set it in form of resistance or in form of conductance. Now, for solar cells, these external resistances affect the current voltage characteristics, capacitance voltage characteristics, and capacitance frequency simulation, but it does not affect the quantum efficiency simulation. The voltage which you apply to sample either the working point voltage or in the IV or CV simulation is interpreted as internal voltage over the sample with external resistance. So this voltage also gets recalculated in order to get the external applied voltage for the IV curve and the CV curve. In small signal simulations, the conductance value and the capacitance value are recalculated after simulation. The values of the external resistance are saved in the definition file of the solar cell. So once you enter the values for series resistance and shunt resistance, you are able to save them in the definition file in the simulator. Lastly is the action list. The action list helps you to load predefined actions for simulation. You can also save actions that you want to simulate in future using the save action list. You can load all action settings, which loads saved simulation settings. You can also save all settings, which helps you to save configuration. Now, coming to this part is where you set the problem. When you click on set problem, it takes you to the page where you can load parameters of the solar cell, which involves all the layers of the solar cell. So for instance, if it's a perovskite solar cell, you have to load the front contact, you have to load the electron transport layer, you have to load the perovskite layer, you have to load the hole transport layer, you have to load the back contact. So all of these are being done using the set problem. Now, after you have set the problem, you want to calculate the characteristics of the solar cell. And that can be done using the single shot. The single shot does the simulation just once. The batch shot or the batch calculate does a simulation of several batches of parameters that you've entered. So to be able to use the batch run, you must have used the batch setup to set up different parameters for different solar cells. And when you click on the batch run, it will run all of those simulations at once. You can use the recorder to configure and run time-based or time-dependent simulations. You can also use curve fitting to fit simulated data to experimental results. Now, this is about the set problem region and then the batch setup. On the middle side, we have the result calculation. To calculate the results, once you click on this calculate single shot, the results will be generated and these grayed out buttons will become active. So you can click on any of them to be able to see your results. So the results are the energy band. The first one is the energy band. The second one is the generation and recombination profile of the solar cell. The third one is the alternating current properties of the solar cell. The fourth, fifth, sixth, and seventh are the current voltage characteristics, capacitance voltage characteristics, capacitance frequency characteristics, and quantum efficiency characteristics. Once you click on all of these, you are able to see the result. Now, the last part of this screen is the save simulation. So when you have finished your simulation and you want to save it so that you can be able to open it in the future, you can just click save all simulation. If you don't intend to save your simulation, you can click on clear all simulations, and the SCAPS info just shows you information about the SCAPS software. And if you want to exit the software environment, you just click on quit. Now we're going to look at the software itself and load our first definition file. I'll just click on the shortcut for the SCAPS simulator. I've sent it from the program files to the desktop so that I can easily access it. So I'll just click on this, and you can see the SCAPS software is launched now. Now, like we have just looked through our presentation, this is the working points, this is the action list points, this is the illumination section, this is the action section, and these are the set problem section. All right? So the software also comes preloaded with the temperature, the voltage, the frequency, and the number of points. Now we want to use the light mode, so I'll just switch this button to the light section. You can see the spectrum, the solar spectrum is already loaded. We have the solar irradiance set at 1000 watts per meter square. Now I can decide to change the solar spectrum by clicking on select file. If I click on this, it gives me a list of already existing solar spectrum that SCAPS software comes with. So I don't want to change it. It's already on Airmass 1.5, so I'll just leave it at that. Now on this part, I want to simulate the IV curve of the solar cell. I want to simulate the capacitance voltage. I want to simulate the capacitance frequency and the quantum efficiency. I'm going to leave all of these like this. They are already preloaded, but I'll check this box so that once the open circuit voltage of the IV curve is reached, this stops the simulation for the IV characteristics. On this other side, you can see the points. They are all already preloaded. I'm going to leave them also. Now, let me just click on Set Problem. Once I click on Set Problem, you can see that it gives me the ability to load the layers of the solar cell. Assuming I want to work on the perovskite solar cell, I'll click on this and I'll label this place maybe the first layer. But I don't want to do that. I want to load a pre-existing solar cell. So I'll just click on Cancel here. I'll come to this place and click on Load. Once I click on Load, I'll go and select any of these definition files. These are all different solar cell definition files that comes with the SCAPS simulator. So I'll select one of them and we'll use it to complete this tutorial. So I'll just select the cadmium telluride definition file and click on Load. So once I click on that, you can see the interface is loaded with the layers of the solar cell. The first layer, the left contact, the right contact, the cadmium telluride, the cadmium sulfide, all these layers are already loaded. So I'll just click on OK and it will take me to the action panel where I can now simulate. So now that I am on the action panel, my solar cell parameters has been loaded. My actions that I want to check the characteristics are also been loaded. I'll just click on the calculate using single shot. Once I click on this, it will start calculating the characteristics of the solar cell. So you can see immediately I clicked on the calculate, it started to do this calculation, and based on that, it has been able to generate some graphs. This is the band diagram of the solar cell. The band diagram showing the electron volts and distance. This one is showing the current density and distance. This one is showing the current density and distance. And this one is also the electrons and distance. So we'll be looking at all of these in details later, but right now what we want to focus on is the IV characteristics, the current, the capacitance voltage characteristics, the capacitance frequency characteristic, and the quantum efficiency. You can see immediately the simulation was completed, these grayed out buttons became active. All right, now I can click on the IV curve to see the IV curve. So I'm on the window where the IV curve is showing. You can see the IV curve is showing the open circuit voltage for the solar cell that has been entered. It is showing the short circuit current, it's showing the field factor, and it is also showing the efficiency. All right, this is a graph of the current voltage characteristics. Now we also have on this side the recombination current. It's the graph is also showing. Now we can go and see the capacitance voltage curve. If I click on this, it takes me to the capacitance voltage curve. As you can see, this is the capacitance against voltage. This is also Schottky curve is showing the inverse of capacitance with voltage. This one is the conductance, showing the inverse of resistance to voltage. And this side is the doping profile. So in future videos, we will be learning more about these graphs and how to understand them. Let's look at the capacitance frequency curve. You can see the capacitance frequency curve also. Here is frequency against frequency, capacitance and frequency, capacitance against frequency. This is the Nyquist plot. This is the conductance plot. This is also the conductance plot, right? Now let's look at the quantum efficiency plots. You can see the quantum efficiency plot. This is quantum efficiency against wavelength, right? Now we can go back to the action panel from this graph just by clicking on the action. We are back to the action panel. Like I said earlier on during the PowerPoint presentation, you can see from this section that this results section has now been activated. I can click on the energy band to see the energy band graph. I can click on the conductance, resistance button to see the conductance and resistance graphs. I can click on the AC to see the alternating current graphs. You can click on IV curve to see the IV characteristics. I can click on any of these to see. So let me just click on IV and go back to the IV curve. Now I am on the IV curve. We can see all the calculations and all the numbers that were generated during the calculation. So you can see these are the parameters that are plotted on these graphs. This is the voltage, this is the current. So these parameters are what you are seeing on all of these graphs. So you can copy them and plot them in any of your most preferred software if you want to. You can also save your graph and you can look at the plot legend. You can see the plot legend. In future videos, we'll be looking at all of these and understanding them better. But for today, we are done with this simple presentation on how to load a definition file from your software. Like I said earlier, you can save your simulations, you can clear out the simulation. You can also view information about SCAPS by clicking on SCAPS info. So I'll just click on SCAPS info and you can see it shows you name of the software, the version of the software, the developers of the software, the contact information of the developers, the algorithms that were used to develop the software, and the copyright issues. You can see these are all what you find in the SCAPS info button. And then since we are done with the presentation, I'll click on quit. I don't want to save, I'll just click on yes and exit. So since we are done with this presentation, I want to say a very big thank you for listening. I hope you enjoyed this tutorial. And to recap what we have just done in this tutorial, we just learned how to load our definition file from the already existing SCAPS software sample programs. In the next video, we'll be looking at a specific solar cell in details and how we can load different layers. Thank you very much. And if you enjoyed this video, please consider subscribing and giving it a like and share with your friends. Thank you.